All right, so we're going to do 8.5 today. And hopefully it goes well. I think it will. So a bag contains 6 balls numbered 1 through 6. A ball is drawn from the bag and then it's returned. This is important. A second ball is drawn from the bag. In how many ways can a total of 8 be obtained? So just think about the situation for a second. You have these numbers 1 through 6, right? You're going to draw out 1, and then you're going to put it back in, and then you're going to draw a second number. And we're trying to add up to 8. Okay, so let's just kind of list it out. Let's list out the possibilities. So here's the first draw, and then here's the second draw. Okay, so could I draw 1, and then on the second draw be able to draw a number that adds up to 8? No, because 1 plus 6 is the highest combination I get is 7. So 1 is not possible in this situation. So how about a 2? If I drew a 2, what would I have to draw a second time to get 8? Good. And then 3, 5, and then how about 4? Am I allowed to do that option?
Yes. You put the ball back.
Because it's been returned. So I draw the 4, I write down my, answer, and then I put the 4 back, and so I could draw it again. So 4 is a possible way here. How about 5? 3, and then 6 and 2. Okay? So how many ways are there possible? 5. So in example 1, what we just did, what if I did not replace? So what if I didn't put back the 4?
You couldn't do the 4.
This is the only option I wouldn't be able to do, right? So the 4 option would no longer exist. So how many ways would be possible now? 4. Okay, so this is a situation where you can just think about what's happening here, and then you can make a list. You have minimal ways here, right? So it's feasible to make a list. Sometimes it's not. Like when you have hundreds of ways to do something, you would never want to list all that out. So we have to have a way to do this instead mathematically. So this is what you would use, the fundamental counting principle. So you have a couple events, whatever is happening here. So in this case, we just had 2 events, the first draw and the second draw. Okay? You want to think about how many things or how many ways are possible within each event. This is like that M sub 1. Okay? So in event 1 and event 2, there are so many ways in each event. If these events are independent, all you do is you multiply them together, the number of ways available. You just multiply them together. So we're going to take a look at this and do some problems that require that. Okay? All right, so let's take a look at example 3. How many different pairs of letters from the English alphabet are possible without replacement? So a couple things. First of all, we're looking for pairs of letters. So pairs, doesn't that mean 2? So there are 2 events, right? Event 1, and then there's event 2. We're talking about the alphabet. How many letters are in the alphabet? 26. That is an important number to know in this unit, okay? So there's 26 numbers or letters in the alphabet, and then it says that it's without replacement. So we're going to pick 2 letters, and we're not going to replace. So how many letters are possible in the first event? 26, right? Then I'm going to draw out a letter. Let's say it's an A. Now I can't put the A back because it says without replacement. So how many letters are possible in the second event? 25, and you just multiply these together because they're separate events. So 26 times 25 gives us 650. And then ways. You would never want to make a list for 650 ways. Okay, we want to graduate on time. All right? All right, how many 3-letter words, including nonsensical words, could you create from the English alphabet? So let's talk about what that means. So a nonsensical word is a word that's not a word, like ZZQ. Not a word, but it counts in this as our 3-letter word, okay? So what does that mean? Does it mean that you're having replacement or no replacement? Are there repeats, no repeats, however you want to think about it? So there's replacement or there's repeats available. Okay, so we're having a 3-letter word. So we have 3 events now, right? So how many letters are possible in the first event? 26. And how many are possible in the second event?
26.
And in the third?
26.
Good. So 26 times 26 times 26 gives us 17,576. 3 separate events. Think about the possible outcomes, multiply them together. In a certain state, each automobile license plate number consists of 2 letters followed by a 4-digit number. How many distinct plates can be formed? So when it says how many distinct plates, it's saying like, I can't have the same license plate as you. We have to have different ones. Okay, so we don't have to worry about, having to count these multiple times. Now, think about the events that are occurring. So let's just kind of lay out the license plate. What would it look like? So the first 2 are going to be our letters, right? Then we have 4 digits. So all of these count as digits. Thank you. Now, all of these are separate events, right? Think about a license plate. Can you have repeated numbers?
Yes.
Yes. Could you have repeated letters?
Yes.
Yes. So now we want to think about each event. How many possibilities are there within each event? So how many letters are possible in the first one? 26. And how about the second letter? 26, because there are repeats available. Okay? Now we're going to move into the digits. So think about a digit. A digit could be from 0 to 9. So how many are there? 10. And since there is an availability of repeats here, it's going to be 10 times 10 times 10 times 10. So 6,760,000 ways. Everybody okay with that? It's really the same thing that we did in the first example. It's just you would never really want to make a list. Okay? So, a permutation is ordering n elements. So order matters here. This is what you need to remember. With a permutation, order matters. Every single thing has a position. So if I said I was going to line you guys all up, order would matter, right? Wherever I was in the line, you couldn't be in the line. So that position's been filled. If you say something like you're going to make, a batting order, or there was like first, second, third place, or there's positions on the board like the president, the vice president, the secretary, things like that. All of these are situations where order matters. Do you understand that? Okay, so this is the idea of a permutation. Now, I am never going to word a question like example 6. I'm never going to say how many permutations of the following are possible, because that's telling you, use a permutation, order matters. I'm never going to do that. Okay, you have to realize that order matters, but this is an example that we're going to do. So we have this word shaker, and we want to figure out how many permutations, so how many orders can I create from these letters. So let's think about it. So it's like we're going to line up these 6 letters. Once the first position's filled, it's no longer available, right? So once I put a letter here, how many letters are possible in the first position? 6 letters, because there's 6 total letters to choose from. So once I've put a letter there, how many are possible in the next position? And then the next, and the next, and the next, and the next. And then what you do is you multiply all of these together. Well, what is 6 times 5 times 4 times 3 times 2 times 1? 6 factorial. So with the permutation, you're going to use factorial. Okay? Because order matters. So every time you fill a position, there's one less option available. So this is 720. Okay? This might be more of the wording I would use in like example 7. How many ways can 8 children line up? Right there, that lineup is telling you order matters, because once you fill position 1, it's no longer available, right? You can only have 1 line leader. It's unfortunate. All right. So what do you do here? 8 factorial because order matters. So you can do 8 factorial in the calculator, right? You could take the time to multiply it all out. You get 40,320 ways. Do you remember where the factorial key is in the calculator? It's under math or order probability. I think it's option 4. Okay. Everybody okay so far?
Yeah.
How many ways? How many miles?
Yep. Number of permutations of n elements. So sometimes you don't want to order all of those 8 kids up. Sometimes you want to select a subset of them and order those kids up. Okay? So this is what you're going to do when you're using a permutation, but you're taking a subset of it. So you have to memorize this formula here. Now, the calculator will do this for you, but on the quiz, I'm going to ask you to show me the formula. So you have to know it, right? You have to be able to use it. You can use your calculator to check. There's no example here. Somehow it got deleted. We have to put it in here. So write small. Example 8. A coin club has 5 members. In how many ways can a president and a vice president be elected? Aren't you so glad we have this note packet? You don't have to write out every single example like this. It would take forever. Okay, so you have 5 people to choose from, but you're filling these 2 positions. Do you see why order matters? Once you fill the president's position, there's only 4 possibilities left, aren't there? So this is the case where you're going to use the permutation, selecting n number. R number of elements. So n represents your total number to choose from. So how many total are there to choose from? I will be in the little. I guess you can. Okay. So 5. Right? 5 to choose from. And then how many are we choosing? What's the subset? 2, because there's 2 positions to fill, the president and the vice president. So 2 positions to fill. So now you just plug in the formula. So I have 5p2, which is 5 factorial over 5 minus 2 factorial. Well, simplifying this, we have 5 times 4 times 3 factorial, right? Over what? 3 factorial. So we get those 3 factorials to cancel, and we get 20. Now, if you were to use a calculator, you could type in 5, math, here over to probability, NPR, which is option 2, and then choose 2, and you get 20. Okay? You're going to have to show me this, but you can verify using this. Oh, sorry. This? Okay. Any questions? Keep going then. So we're still talking about permutations. So this is number of distinguishable permutations. So use this when you have repeated elements. So for example, if you think about the word book, there are 4 letters total, right? If we want to order these up, okay, we have to think about the fact that there's these 2 O's. Can you tell the difference between which O is which? No. So you have to use this formula where you distinguish the number of permutations. So you have to remember this. So it's still using factorial. You have n factorial. That represents the number of total letters possible. So in our case of book, we would have 4 factorial over, and now we want to think about the letters. And so we have 2 O's. So you're going to divide it by 2 factorial. because there's two O's, and then there's a B and a K. So technically it's times 1 factorial times 1 factorial. These should add up to the total of 4. Now, we don't usually write the 1 factorial times 1 factorial because it's just 1, right? So it doesn't really matter if we write it in there or not. So this is how you'd have to do a case like this. So here, to find the number of distinguishable ways the letters in mathematics can be written. So when it says distinguishable ways, it's telling you order matters, but you got to pay attention here because we have some repeats. So the first thing we want to think about is how many total letters do we have? 11. Okay, now we want to think about the repeated letters. So there's 2 M's, there's 2 A's, and there's 2 T's. Okay. Yeah.
On a quiz or test, would you use the word distinguishable?
I could say, you know, find the number of ways that the letters in mathematics could be ordered, or something like that. Yeah. I could use that phrase too. Yeah. Okay, so now we're going to take 11 factorial because that represents all of our letters being ordered. But now we want to say that there's some distinguishable permutations in here because we can't tell the difference between those M's and A's and T's. So I'm going to have divided by 2 factorial times 2 factorial times 2 factorial. This takes care of 6 of my letters. There's 5 left, but they don't repeat. So it's really like times 1 factorial 5 times. We don't need to write that. You with me? Okay, so think about 2 factorial times 2 factorial times 2 factorial. Isn't that just like 2 times 2 times 2? So I'm really taking 11 factorial and dividing it by 8, which I'm going to do in the calculator. So 11, math, arrow over to probability, option 4, and then divide that by 8. We get 4,989,600. Okay? All right, what we haven't talked about yet is a combination. So a combination is the number of possible outcomes where order does not matter. So this is like you're just creating groups of things. There's no positions to fill. There's no lineup to do. We're just getting a group of things together. Okay, order doesn't matter. So you would use the NCR option. All right, you do need to memorize this formula as well. Let's take a look here. And how many different ways can 2 letters, or I should say letters, be ordered from A, B, C, D, E, F, G? All right, so you're just going to follow this. So we have a total set of 7 possibilities, right? So that's going to be our N, so N equals 7. We're choosing 2 letters. Let me zoom out a little bit. There we go. We're choosing 2 letters, so R equals 2, and we're just going to plug it in. So I have 7C2. So I have 7 factorial over 7 minus 2 factorial times 2 factorial. Remember, to simplify this, you want to start with the largest number first. So thinking about 7 factorial, I want to get it down to a 5 factorial to cancel if I can, which that's possible. 7 times 6 times 5 factorial over 5 factorial times 2 factorial. All right, we cancel our 5 factorials. We get 42 divided by 2, giving us 21. Now, if you were to do this in the calculator, you would just type in 7, math, arrow over to probability, choose the NCR option, and then we're choosing 2 of those. We get 21. Okay? Last example. For an experiment, 4 students are chosen at random from a class of 20. How many different groups are possible? So these are key words that tells you this is a combination. So I'm just going to take 4 of you out of here, put you in a group, and you're going to work together. Order doesn't matter. You don't have a set role in the group. You're just grouping these students together. So this is an idea of a combination. How many possibilities are there? What's our N? 20. And what's our subset, or R? 4. So I have 20C4. I'm just going to use the calculator for this one this time. So 20 math probability NCR 4. 4,845. Is anybody having trouble with the formula or putting in the calculator? Everyone knows how to do those 3 keys really in the calculator is all we need. NPR, NCR, factorial. Excellent.